how to use what we call co-function identities to solve for inverse trigonometric expressions, okay? So we are going to solve the following. What's cosine inverse of sine pi over 3, okay? Let's read our step number 1, okay? Olivia, go ahead.
It's the outer function of inverse.
Thank you. So this is the inner function, that is the outer function. So check, yes, it is an inverse. Again, the inner is the one enclosed in a parenthesis. The outer is the one outside the parenthesis. So yes, in here, the outer function is an inverse. So check. Okay. Step number 2. All right, Josh, let's read step number 2. Are they
co-functions?
Thank you. When you say co-functions, again, the prefix is co, right? Sine, cosine, right? Tangent, cotangent. Secant, cosecant, right? So those are what we call our co-functions, right? So going back in here, cosine and sine, are they co-functions?
Yeah.
Sine,
Yes.
cosine. So yes, prefix co, that means they are yes co-functions. So check step number 2. These two are co-functions. Again, see that prefix, sine, cosine, okay? After that, what do we do then? Step number 3, all right? Mike, let's read. Use co-function.
Use co-function IDs, co-function
Yeah.
degree equals sine
Pi over 2 minus
minus
theta, all right? Thank you. And the rest are as follows, right? Secant, cosecant, right? Tangent, cotangent. So as you may notice, they can flip as well, right? This can be the cosine and that is the sine. This can be the secant, that can be the cosecant. This can be the cotangent, that can be the tangent, right? So they can flip, all right? As long as, once again, they are co-functions. Now what do you notice about the angles? Theta and pi over 2 minus theta. What can you say about those two angles in there?
Complementary.
Complementary angles, right? When you say complementary, Katie, what do you mean by that? They add up to 90 degrees in degrees or pi over 2 in radians. Are we good? Right? So when you say complementary, let's say what? What's the complementary of 70 degrees? 20 degrees. Are we good? Got it? Okay. Similar to radians, so you can do that one as well. That's pi over 2 minus theta. I'm just implying here is pi over 2 because typically we are giving values by what? Radians, right? But in terms of degrees, you can just change that one to 90 degrees instead. Are we good? Right, so going back in here. So what do we use? The first, the second, or the third? Well, the first, right? Because this is in terms of sine and cosine, right? So what do we have in here? Cosine inverse of sine pi over 3 is that, right? So we got this one already, okay? So first of all, the inner is sine. So this is what I'm gonna do. I'm just gonna change this cosine to what? Sine. And I'm gonna change this one to cosine. Are we good? Right? Now this is the sine theta. Outside of it, I'm gonna put what? Cosine inverse on both sides. So that's what I'm gonna do with that. I'm gonna get a purple pen. So since sine theta is cosine of its complementary, pi over 2 minus theta, I'm gonna enclose this and put cosine inverse because that's what the outer in here is. And I'm gonna do the same on the right side in here, right? So I'm just getting the cosine inverse of both sides. Are we good? Right. Why? Because I want this one to be similar to what I'm getting, right? Cosine inverse of sine of theta. That's pi over 2, right? Now what's gonna happen to the right side? What's cosine and cosine inverse gonna be?
Cancel out.
Max. They will cancel out, right? Very good. So that means what's gonna be the answer in here? Pi over 2 minus whatever your theta is. What is that again? Pi over 3. All right. So what's that? What's the complementary of pi over 3? Again, we can use our calculator for that one, guys. So how do you use the calculator for that? Since there's pi's, I just want to focus on the fractions, right? Half of a pi minus, what's that again? 1/3 of a pi, right? I want the exact value in terms of fraction. What did I get? sixth of a pi. Very good. Thank you, Andrew. So with that being said, what's the answer in here? Pi over 6. Right. Are we good? Right. Now, let's read step number 4. Mike, go ahead.
Verify by decimals.
Yeah. Actually, you can verify the answer really quick. Let's put in here the following. What's that again? Cosine inverse. I'm going to go in here. Oops. Click on functions. Click on cosine inverse. And then put in sine. Parenthesis once again. Pi over 3. Right? Make sure it's in radians. Alright, so it's in radians. What value did I get? 0.52 something, right? It doesn't make sense in here yet. However, to verify, is that equal to pi over 6? Let's see. Pi over 6. Are they the same?
Yeah.
Yes. Right? So yes, you can verify by decimals what the answer is. But no, you cannot get the exact answer just by doing the calculator. Are we good? Right? Get it? But again, you can find ways of doing that one on your end as well, right? But again, good thing is, you can always, be confident with your answer by plugging in your decimals. Oh, okay, pi over 6. Then we're done. Are we good? Get it, guys? Once again, this is when the outer function is the inverse, right? The outer function is the inverse. Definitely the question now is, what if it's not? Okay, what if it's not? So let's find out in here. We got the following in here, right? We got this tangent of cosine inverse of 1 over square root of 5. Okay, so this is what? How to solve inverse trig expression without using the co-functions. Okay, step number 1. Let's read this one in here. Lex, can you see it from there? Is the
inner function an inverse?
So the inverse now in here is the inner. Alright, the inner function. A while ago it's outer, right? In here. The inner function. Where is that inner function? Here is the inner function, right? Is it an inverse? Yeah. Alright, so check. Okay. Step 2. What do we do then in this case? Alright. Jenner, go ahead. Let
angle theta be this inner function. Draw a triangle.
Thank you, right? So you see this inner function? That will be your theta, right? So let theta, your angle theta, be cosine inverse of 1 over square root of 5, right? Now we're going to draw this right triangle like such. Let this be your theta. You can have your theta in there. You can have your theta in here. It's up to you, right? Get it? Okay. Since this is cosine, then we can use this mnemonic for cosine, meaning what? What is adjacent in here? What number in here is adjacent? The 1 or the square root of 5? Huh? 1. Very good, right? So the adjacent here is 1. What is your hypotenuse? The square root of 5, right? So again, since cosine is adjacent over hypotenuse, and that means in here, cosine, that means that's adjacent, that is hypotenuse. Are we good? Okay. Well, let's figure it out on your step number 2. So we put in here, where's O, A, and H? Get it? If this is your angle theta, where do you think is your opposite side? Left, up, or down? Opposite? Left. There we go. Right? Where's adjacent? Up or down? Down. Definitely this is your hypotenuse, right? From angle theta, farthest, nearest, longest. Get it? Okay. Now we put those values. Your A is 1. Your H is square root of 5. Get it? Okay. Well, in a right triangle, if you are given 2 sides, you can definitely get the third side. Okay? How? Let's read step number 3. Get it? Okay. Brian, go ahead. Use
Pythagorean theorem to solve for the other leg.
okay. The third leg, use the Pythagorean theorem, right? So we're looking for what? The opposite side, right? So O squared is equal to adjacent squared, plus, is equal to the hypotenuse squared, all right? Well, we're gonna solve for that opposite side, right? So what's square root of 5 squared? It's gonna cancel, right? Because square and square root are opposites, right? Okay. What do we do then? Subtract 1, right? Okay. So O squared is equal to how much? 4, right? But you just want O. What do you do? Square root, right? Inverse of square is square root. So that's it. What's your opposite side then? 2. Are we good? Okay. Last one. Step number, well, second to the last. Step number 4. Very good. Ed, can you see it from there? Use.
To solve the outer function.
Okay, what's the outer function?
Tangent.
Tangent, right? So, what part in here should we use? Tangent, right? The tangent. Right? Why? Because it says in here tangent, right? So let's use that one. Right? Tangent of theta, that's your theta, right? Okay. Is equal to what? O, what's your opposite side once again? What's your A, adjacent side? It's your O over A. Okay, that basically is your answer, right? Tangent of, what's your theta again? This entire thing is your theta, right? Cosine inverse of 1 over square root of 5 is equal to how much? Are we good? Definitely the last one is, can we use our calculator for this? Well, let's try it. Right? Let's put it in here as follows. So here it is, guys. Plug it in here like such. What's that again? Tangent, parenthesis, what's that again? Cosine inverse. I click on functions, click on cosine inverse. 1 over square root of 5. Make sure it's in radians. Okay. You verify that answer to be correct? Okay. Again, it just so happened that it's an exact integer value, 2. But in most cases, it's a radical value, right? Like square root of 3 over 2 or 2 over square root of 3. In that case, again, we just got lucky that this is an integer value, but in most cases, it is not. Right? It is not as exact as that. So that's why we have to consider those steps in order to analyze this inverse trig function. Right? But the good thing is, we can always verify using our Desmos calculator, TI-84 calculator, if you're getting it right. Are we good?